Hello everyone, here are Geo Notes for section 3.3. We've been talking about transformations in our transformation unit, and we've been talking about reflections, and we've been talking about translations, when you flip and when you slide, and now we're going to talk about rotations, when you turn something around a center point. So that's what this section is going to be about. It's called rotations. Now all of those three are rigid motions. That means they don't change the shape of the figure that you're moving. It's just moving a shape. You're either flipping it over, you're either turning it, or you're sliding it, and it's not changing the shape or the size. A rotation is a turning around the center. This is the distance from the center to any point on the shape stays the same. And every point makes a circle around the center. So here you can see the little plus sign, right, where the center point is. Now we often use the origin as a center, but sometimes you use different points. You just put like a plus sign where it would be, and it says here a triangle is rotated around the point marked with a little plus sign. Oh, gotta get to our comic. Sorry, I almost forgot about the comic. Here's Jason and Paige talking, and Paige is reading here, and he says, "Hey, I read this book. I thought the author got off on some odd tangents for a lot of it, but overall most of the points were good, and it raised some interesting parallels. I liked how it came full circle in the last chapter." And she's like, "Jason, it's a math book. 2 pi r. Woo, what an ending." So, Jason's my math guy, and I like Jason. All right, there we go. Here is a little animation that you can check out for rotations. You can see this. This is rotating around a point inside the shape. You can rotate inside, outside, on. You rotate on a corner. There's lots of different places where you can do rotation, and you can see the distance from that center to that point never changes, and it's the same for all the points. The distance around all those points never changes. So that's a rotation, and that's a rotation inside the shape. But this is where you want to get to. This is what's on your notes next. So if you look at the next part of your notes here, you're going to take this red triangle. You're going to click on the red triangle. You're going to put 90 and 50 and 50 because we want to rotate it around this point so you can see it a little better. And then we want it to rotate a 90-degree angle. And then you're going to draw on your picture what you see. So when you click the red triangle and you put in 90, just click 90 there and click 50 here and put 50 there, and then here can't quick rotate, you won't see the actual angles. We want to actually click rotate so you can see that it's making a 90-degree angle from each point. Each point's making that 90-degree angle, and then it shifts it over. So this is what you want to draw on your paper, and it should look like this. You can see the plus sign is where they rotated it, and then we rotated it over. Now, I do want to show you those 90-degree angles just so you can see them. So we had one of those, like this first point right here becomes this point right here. These 2 points get rotated, and the rotation you can kind of see it makes an exact 90-degree angle right there from this point to this point, and it works on all the points. I mean, I could take this back bottom point here. I go through my rotation point, and I go back to this point, and it makes the same 90-degree angle. And I could take that last point right here and go to this point right here, and it makes that same 90-degree angle again. So all of those make 90-degree angles with the center point. And they're all the same distance away. So if this one is this blue one is this long here, it's going to be the same length here. The length is going to be the same as well. So you can make sure you draw that in. You can pause the video if you need to. The second one, I do want you to click on this shape here, the orange shape. Put in any angle you want and any point of rotation that you want. You can put the origin 0, 0 if you want, but don't put a 0-degree angle. That's cheating because that's not going to rotate and it's going to be the same. Don't put 360 because then it's going to go all the way around and be the exact same shape again. So put in a different angle that you can actually draw a different figure on there so you can see the rotation. So and then you can see that each point is rotated the same angle and the same distance from the rotation point. All right, you can pause the video to do that. I'm going to move on to the next page here. Here's a couple of examples. One of them rotates around the origin. The other one rotates around the point 1, 1. This one's a little more challenging because you've got the different point 1, 1. Same concept though, so they shouldn't be too bad. And a lot of times you can just spin your paper around. If they're telling you to go 270 counterclockwise, 270 would be 3 turns. Each turn could be 90 degrees. There would be 90, there would be another 90, that'd be 180, and there would be another 90, that'd be 270. You can actually turn your paper, physically turn your paper 3 turns, and you would see your triangle over in this quadrant over here. And we could get our new coordinates. J was the point -5, -9. J prime is going to be -9, 5. So if we put that in here, it's -9, 5. And then K was the point -5, 0. K prime is going to be 0, 5. 0, 5. And then L, and you can kind of see a pattern here. The -5 becomes the opposite in the back, and the Y just comes up to the front. -5 becomes the opposite in the back, and Y comes up to the front. So if that's right, then the 0 would stay a 0 in the back because you can't do the opposite, and this -9 would come up to the front. So this should be -9, and this should be 0. Let's see if that's correct. -9, 0. Yep, there's L prime. So our formula then, we just figured it out, our little rule would be that you put the Y in the front, you don't change it, you just put it in the front, and you put -x in the back. So Y -x would be your little rule there for that rotation. Now this one's a little more challenging because you've got a different point in the center. You've got the point 1, 1. So I'm going to draw the little plus sign where 1, 1 is. You should probably do that on your paper as well. The little plus sign, that's the rotation point. So that means that we need to draw a 180-degree angle from all 4 of these points through this plus sign, the same distance on the other side. So look at H here. H, you go up 2 and over 1, 2, 3, 4, 5, 6, 7. So if I draw a 180-degree angle, I need to go from this point, I need to go the same distance. I need to go up 2 over 1, 2, 3, 4, 5, 6, 7. It'll be right there. So let me shorten that up so I put it right on the point that I need. Okay, let's double check that and make sure. 1, 2, 1, 2, 3, 4, 5, 6, 7. 2, 1, 2, 3, 4, 5, 6, 7. Okay, so let's make a dot there. Let's change. Okay, so let's put that. That's going to be H prime. H prime right there. Okay, the next point, G, needs to do the exact same thing. G needs to make a straight line up 2 and over 9 because it's too farther away. And so we need to go straight line up 2 and over 9 is going to put us right there. So up 2 over 9, this is going to be G prime. So let's put that in. So what that tells me is that the shape is going to look like this. So we go 1, 2, 3, 4, 5, 6 is the length of our shape. So if I was to now take a different color, okay, if I was to go here and go 1, 2, 3, 2, 3, 4, 5, 6, 2, back down 6, 2, that's going to be my rotated shape. Let me just make that clear so you can see it a little better. It's thick. There you go. So there's your shape. So this is H prime came to here, G prime came to here, F prime is going to come over to here. So let's put that as F prime. Make a dot for it so you can see it. And then E prime is going to be this last one here. So F that's 180. Now, if that worked out right, if it worked out correct, hopefully it did. When I draw a 180-degree angle, straight line from E to E prime, it should go right through the point 1, 1. Please work. Come on, you got this. Yes, there it is. 180-degree angle from E to E prime right through the point 1, 1. And the same thing should happen with F. Should be able to go F to F prime, and it should go right through the point 1, 1, which it does. Each point made a 180-degree angle to the next point through the rotation point. This is called the center of rotation here. All right, so let me get rid of those 2 lines. We just want to draw and put in the points here now. So E was 8, -7. Now E prime is 1, 2, 3, 4, 5, 6, 7. Okay, E prime is 6, 7. So what happened? The y's became opposite, so that might probably be a good thing to put there. The opposite of y. X, we lost 2. So maybe we could put like x minus 2. Well, let's test that and see if it actually works. So x minus 2 and then negative y. So if we apply that, it should be 8 and 7. 8 and 7. So let's see if that's f prime. 1, 2. Oh wait, I messed up. Sorry. This is -6, 7. Okay, there we go. -6, 7. So this would actually then be -8. Oops, -8, 7. Let's try that. So that's not going to be x minus 2 anymore. Sorry. It looks like it's going to be the opposite of x plus 2. So let's see if that actually works. Opposite of x plus 2. Because if you take the 8, make it opposite of 8, which is -8, and then add 2, you get -6. -10 plus 2 is -8. Good. So this is going to be -8. And then we're going to do the opposite, so we're going to do a +1 here. And then here you're going to do another -6. And you're going to do a 1. So let's see if that actually worked for the rule for these points. H prime should be -6, 1. -6, not 1. Oh, these are 9s, not 7s. Man, I'm really off today. Why aren't you guys telling me I'm making these mistakes? Oh, you can't. You're just listening. All right, let me just make sure that's right. So E prime would be -6, good, and 9. I don't know what I was thinking 7 for. Man, I'm just off. Okay, so it's actually then going to be the opposite plus 2. So we're going to need to add the plus sign and 2. Alright, so those should both be 9s. These are both going to be 3s, so then that does work. That rule does work. Alright, sorry about messing up on that one, guys. We still got it right. It just took us a little longer to get to our rule. -x plus 2, -y plus 2. Huh, you know what happened? We had both plus 2s. Wonder why. I know why, because we were at the point 1, 1. And 1 plus 1 is 2, so we're going to add 2 to both of our opposites there. And if you notice, it's a 180-degree rotation, which means you're probably going to do the opposite of x and y if we were just going around the origin. So that's a pretty cool thing to think about. Math is cool sometimes. All right, moving on to the next one. What are the coordinates of the vertices after rotation 270 counterclockwise around the origin? If you want to try this one first, before I do it, I would love to see that. I would love you to pause the video, try it, spin your paper, see if you can find the coordinates, write them in, see if you can find the rule. But I'm going to do it right now. So if you want to pause it, do it now. All right, here it is. We're going to do 270 counterclockwise. So there's 90 counterclockwise. There's 180 counterclockwise. 270 would be that. Let me move this so it's just right on. That would be where we would want to go. Oops. Okay, so right there, these would be the new points. So it looks like L prime is 1, 2, 3, 4, 5, 6, 0. So 6, 0. Actually, L prime, sorry, my bad. Right there, 6, 0. Okay. So it looks like X came to the front. I mean, the Y came to the front. I think we did that last time. Wasn't our 270 counterclockwise? It was Y negative X. So we already learned that one. So let's see, let's apply that. So it's going to be Y negative X. Y negative X. Okay, so does that work for L? Y comes to the front, good, and negative 0 would just be 0, good. So if we applied that to J up on top, we would get the point 3 and then 9. Is J prime the point 3, 9? Over 3, up 9. Oh, there it is, J prime. Got it. If we do the same thing for K, the 9 should come to the front. Okay, so we get a 9. And we should have a 9 in the back, too. So 9, 9. Let's see, is K prime 9, 9? Let's check it. Please be 2, 6, 7, 8, 9. Bam, got it, K prime. Sweet. Okay, so those are correct. That is the correct rule. And you can see when you're going around the origin, if you rotate 90 degrees, it's going to be negative yx is going to be your rule. If you rotate 180, you're just doing negative x, negative y. And we kind of saw that here. We had negative x, negative y. We had to add the plus 2's because the 1 and 1, the 1 plus 1 made 2 there. And then 270, we just figured it out, was y negative x. We did it on 2 of them, and it worked on both. So anytime you're rotating around the origin in a counterclockwise positive direction, going this way is a positive angle. You start here and you move your way up. So those are all your little formulas, your little rules. All right, there is a double reflection theorem for rotations. And it's an image created by two successive reflections over two intersecting lines is a rotation. The angle of rotation is twice the angle between the intersecting lines. The double reflection theorem for rotations is used below to create a rotation of segment AB. So if you flip AB over the y-axis, and then you flip it over the x-axis, you're actually going to make a 180-degree rotation. This A is going to rotate down to A, B is going to rotate down to B, and it's going to be exactly 180 degrees because the angle here is 90, so if you double 90, you'll get the 180. So there's your intersecting lines angle, and there's your rotation angle. Actually, I messed that up a little bit. A should go up to A, my bad. I don't know if it's going to fix it, I'm going to try. A should go to A, there it is. B should go to B, and so on. Actually, I was right to begin with. The problem that I had is that I switched these two. My bad. The A is going to stay around the outside, and then the B is going to stay on the inside. My bad. So you can see 180 degree was the rotation angle, 90 degree was the intersecting lines. So down here, here's your center of rotation. These are not exactly 90 degree angles, so your rotation angle is not going to be 180 degrees. But the angle of rotation is always twice the angle between the lines, as you can see, 90 to 180. So, and down here, the blue angle, the blue arrows represent two reflections. So you're reflected here, and then you're reflected here. That would make a rotation of the first one to the last one. So the red arrow shows the rotation, and it would be double whatever this angle is right here, would be the angle of rotation. That's a double reflection theorem for rotations. You can pause it if you need to catch up. But let's have you try it. Okay, so if you reflected it across the x-axis and then across the y-axis, we've done reflections. I would love it if you would pause the video and do your two reflections and see if you're right, because I'm going to show you in a second. But I would pause it and I would do the two reflections and see if you can see the rotation. All right, here it is. Remember, we're back. If you've paused the video, we're back now. So if you reflected it twice, if you went across the x-axis and then across the y-axis, so you flipped it here and then you flipped it over here, that would make a single rotation of 180 degrees because you flipped it over two 90-degree angles. Here would be the points, Q prime, R prime, S prime, and Q double prime, S double prime, R double prime. So if you wanted to plug those in, which would be difficult now, Q prime would be the point -8, -5, -8, comma, -5 would be Q prime. And Q double prime would be 8, -5. So is there any kind of rule here? Well, -8, negative, so you could do an x negative y here. So this should be, x would be -8 and then -8, so you should have two -8s. And that is definitely R, so that's good. And here you have -3, -6. That is definitely S prime. So -3, -6. Oh no, that's -7. Oh, whoops. That was a little. 1, 2, 3. 1, 2, 3. Oh. 6. I got the 8 down here. -5. Right. I should be at 8. Oh, I just messed this point up. That's all it is. This point should be up 1 to there. That's what I did wrong. I didn't reflect this S prime correctly. So if I could fix that, I will. Oops. Okay, so that actually should be over here. And this should be up there. That's more the picture. And then S here should be above. I wonder why my line wasn't exactly through the origin. Now I know why. Stick it here. And this line. Perfect. Look at that, right through the origin. That's awesome. Okay. So now we can get the correct point. So it's going to be -3, -6. Good, we did that right. Okay, this double prime, we switched the x and kept the y. So we're going to switch the x. So our double prime should be 8, -8. And let's see if that's correct. So over 8 and down 8 is correct. Okay. And then this one, we should get a 3 and a -6. 3, -6. And that should be S prime 3 and -6. Good, perfect. Okay. So that is 180-degree rotation through the center point. That is actually a clockwise rotation through the center point. All right, guys, there are your notes, and we'll see you guys later.